Okay, welcome back to talking about Part 4, Ceramics Part 4. We're now going to talk about cements. Now cements are materials formed by complex reactions. When aluminium oxide, soda and lime are reacted at high temperatures. They're strong in compression but they're weak in tension, but cements can take up to 28 days to reach 90% of their strength. And the reaction takes place when cement cures is an exothermic reaction, so it releases heat, and that's one of the reasons why you see the cement being hosed regularly whilst it's curing. So just to recap, cements are binders, so they're a material that's used to bind harder substances. And the most common mixture of Portland cement, which is the cement that we use at the moment, are mixtures of aggregate. We use this silicon rock, or not silicon rock, it's an igneous rock, what is it again? Basalt, broken up basalt. It's very hard, very tough, can be graded in different sections, and it provides the wearing and strength properties. And that mixed with sand, which is commonly occurring sand, like beach sand, plus the binder of this cement creates concrete. So concrete is a mixture of all three, a mixture of cement, sand and aggregate, and cement is the actual binder that holds the aggregate and sand together. Okay, so we've discussed Portland cement, we've spoken about it. It's made up of several different items. Typically when it's mixed, you'd use a ratio of 4 parts aggregate, 2 parts of sand and 1 part by volume of cement to create concrete. Now that's just a standard kind of mix, but that can be altered and changed as required. Too much water will provide problems for you, so just the right amount of water, and there are tests which you know about, some slump tests to test the consistency of the concrete. Now the ancient Romans used a cement which is different, called pozzolana cement. Pozzolana cement was developed using mainly silica, which is the sand that you know about, aluminium oxide and iron oxide. And they were all mixed up with lime, which contains high in calcium, and water, and they were ground to a powder, and with some heat treatment, when the water and the aggregate were added, they had a strong form of concrete. And just to show you what the Romans could do with that concrete, most likely their crowning achievement was the Roman Pantheon, and here it is here. So built, in the early few hundred years of AD. Here is this whole entire massive roof, which is more than 25 metres a span, was all made out of Roman concrete, formed up and moulded on site. And you can see it's an impressive looking building. So that was the construction of the dome. You can see by the size of the people here exactly how large this building really was. So the same process will take place today. Concrete needs to be formed, and here's the formworking set up over here. And you can see the mixing process and carrying it and then shaping it and screeding it and pressing it into position. And because of the great weight of this dome, often empty things or objects were used to fill in to create voids, like amphorae, which were the vases used to hold their wine. And they were often thrown in there, empty ones, to create voids to lightweight this the massive dome that was set up around here. So ancient use of pozzolana concrete. Pozzolana, the technology was lost when the Roman Empire collapsed, and for many hundreds of years, and Portland cement was devised in the 1800s, and that's what we now currently use. So pozzolana being the ancient Roman. We're now using typically Portland cement, named after the place in England where it was credited to have been created. Alright, so in creating Portland cement, so let's go down here for Portland cement. We've got a mix and grind crushed limestone and shale. So we've got crushed limestone and shale, and that's heated to around 1400, fired to around 1400 degrees Celsius, very hot. And then some gypsum or calcium sulfate is mixed in. And by the way, this is around about 2% calcium by mass is calcium sulfate. And this stuff here, the crushed limestone and shale, is called clinker. Mix in the calcium sulfate, and then all of that combined together is ready. It's a fine ground to a fine powder, fine grey powder, and you have Portland cement. Now, when you add water to the Portland cement, a silica gel is formed. So you add water, you get a silica gel. And when the water evaporates, that silica gel becomes hard, and this reaction takes place in air, or it can also take place underwater, which is interesting. So these are called hydraulic cements. That is, cements that use water to be able to set. There are non-hydraulic cements as well. That means that they're cements that will set purely in air. These ones require water, they're the most common. So these are hydraulic cements. On the other hand, non-hydraulic cements, they set in air, and they can't be used underwater, so if you put water in them they won't set. They use lime, and they have alumina, which is aluminium oxide, and iron oxide. They're heated to around 1000 degrees Celsius, and that produces calcium oxide. And eventually water is added to produce calcium hydroxide. And that's called hydrated lime. And then that your non-hydraulic cement is ready. As well as that, there's some material, I think, added called gypsum. Gypsum is added, and gypsum is calcium sulfate. I think that's added to the mix there as well to create your non-hydraulic cement mix. Just remember that the cement is a binder and is added to sand and aggregate to create bulk and strength and wearing properties. So that's the use of cements. Okay. I think that's about all I need to tell you. Well, there it is, ceramics. Hope you've enjoyed that. I hope it's clear to you anyway.